Okay, here are the few questions that you guys asked me to solve from the MCQs. Alright, question number 37. It says that the loss in mass at anode is 50 grams, whereas the gain in mass at cathode is 45 grams. Now, this is a question about electrolysis, and you will probably study that in the next term, but you have studied the topics about percentage purity. Alright, so you should be able to solve this. We have studied the formula of percentage purity, and the question, by the way, it asks us to calculate the percentage purity of a node, and the percentage purity is given by in moles. We've studied that experimental value upon the theoretical value, right? Experimental value upon theoretical value times 100, and in this case the experimental value is 45 grams because that is what we obtain. Alright, we get 45 grams at cathode, whereas ideally it should have been 50 grams times 100. You do this calculation and you will get the percentage purity. 45 upon 50, that's 90%. Alright, so your anode was 90% pure. Rest these 5 grams were impurities in it. I hope it made sense. In the next part, MCQ 40, the question says 8 grams sample of oxygen atoms contain same number of atoms as 16 grams of element X. We need to find the AR, the relative atomic number or relative atomic mass of element X. Alright, so we all know moles is given by number of moles upon AR or MR in the case of molecules. And alright, so let's just calculate the moles of this 8 grams of oxygen. Alright, and these will be moles as mass is 8 grams and AR for oxygen atoms is 16. Alright, so it will be 0.5 mole. Now we know that same number of moles contains same number of particles. Alright, 1 mole of everything contains Avogadro number of particles, and 0.5 moles of everything, it should contain half the Avogadro number of particles. Alright, if the number of moles is same, then that means the particles are same. Alright, that means the atoms are same in this case. Alright, so we know that it should have 0.5 moles and the mass given is 16 grams, and we need to calculate the AR. Alright, coming from the same formula. So AR will be 16 divided by 0.5, that is 32. 32 will be the relative atomic mass of element X. That I guess is sulfur. Right. Let's move on to the next question. It is 41. Now, the question asks us to calculate the mass of water in copper sulfate .5H2O. That is the hydrated copper sulfate. Alright. So the MR of copper sulfate given is 160. MR of water is 18, and we need to calculate the percentage by mass of water. What mass of water is in this hydrated copper sulfate crystals? Okay, so whenever you want to find the percentage, it is the same as you calculate the percentage of your marks. Your obtained marks divided by your total marks times 100, that gives you your percentage of your marks. Alright, similarly we'll do it with the water. It will be the mass of water that we need, alright, in place of our obtained marks, and the total marks or the total mass of compound times 100. Alright, so the mass of water, the MR of water is 18, and we have 5 molecules of water. That will make 5 times 18 is the mass of water, and the total mass of compound is of copper sulfate is 160, plus we have 5 molecules of water. The total mass is 5 times 18. Alright, this will be multiplied by 100, and if we do the maths, then it should give us 5 times 18 upon 60 plus 5 times 18. This is 60%. Alright, 60% of this hydrated copper sulfate is water. I hope it is clear now. MCQ number 23. An element forms a hydride of EH4 which contains 90% by mass of E. AR of hydrogen is 1. The exact same question that we've done over here, but we need to go in reverse now. Alright. It says that 90% is E. Alright. Percentage of the same formula. Percentage of E will be calculated by the mass of E upon the total mass times 100. Alright. So the percentage is already given. It is E. It is 90, and the AR of E is unknown. AR of E is unknown, but we do know that AR of hydrogen is 1 and we have 4 hydrogen atoms. Alright, this times 100. Alright, so if we do the calculations over here, then it is 90E plus 4 9 36, 360. Alright, this will give us E times 100. Okay. So if we want to bring E on the same sides, then it will be 360 equals 100 minus 90, 10E. So 360 upon 10 is E, and that is 36. Alright? Yes, that is the AR of E now. Atomic mass of E. A very interesting question. Element L and element M. The atomic structures of two elements are given. What is the mass of 1 mole of this compound? Before we calculate this, we need to know what will be the compound form. Now M has valence electron equal to 6 and L has 1 valence electron. Alright, so we can safely say that L is in group 1 and M is in group 6. Alright, so the compound formed will be M needs 2 electrons and L can donate only 1. So the compound formed will be ML2 because 2 elements of L, 2 atoms of element L will suffice the need of 1 atom of element M to complete their octet, to complete the octet of M and the duplet of L. Alright, so this is the compound formed. Their nucleons are given. 3 plus 4 is 7 nucleons. That means the AR is 7 and AR will be 8 plus 8 is 16 for element M. Alright, now we have ML2. ML2, that means 16 for M plus 2 times L. Alright, 7 2s are 14 plus 16, that makes 30. 30 is the mass of 1 mole. 30 grams is the mass. 30 is the AR. Alright, and the mass of 1 mole is equal to the AR. We know that mass of 1 mole is equal to the AR. Alright, AR is 30, so the mass of 1 mole will be 30 grams. AR is in atomic mass units. The AR of one atom, of one molecule of this AR of this element is 30 atomic mass units, and when we convert this to mass, it becomes 30 grams. Alright, let's move on. Which equation represents the reaction between HCl and NaOH? Alright, I have not written the equations because I have not given the options that were given, but I need to tell you how it works. Reaction between HCl and NaOH. Alright, I have written the equation, the reaction between HCl and NaOH. Now this is a reaction between acid and an alkali. And when an acid reacts with an alkali, we call this reaction a neutralization reaction. Alright, now all we are concerned about from this neutralization reaction is H positive from acid and OH negative from alkali, right? Because this is what forms water. This is the product of neutralization, right? The salt is formed, no doubt, NaCl, but both of this, the salt is aqueous, all right? So the neutralization equation is characterized by acid and alkali. H from acid and OH negative from alkali. H positive from acid, OH negative from acid, and it forms water. Now this is the equation for neutralization. MCQ 66. 0.5 mole per decimeter cube HCl is added gradually to a flask containing 20 centimeter cube of 2 mole per decimeter cube NaOH. What is the volume of HCl? The first thing that you need to do is write down the equation for the reaction so that you can calculate the moles. Alright, and once you have the equation, you can see it is already balanced. So we can move on to the formula, that is mv over n for acid is mv over n for alkali. Now m for acid is 0.5, it is the molarity. 0.5 and the volume is unknown. Volume, we have to calculate that. And number of moles, n is the number of moles from the equation. We can see it is 1. Alright, now this has to equal mv over n for alkali if it neutralizes. Alright, the molarity or the m for alkali is 2 moles per decimeter cube. The volume for alkali is 20 centimeter cube. And number of moles from the equation is again 1 mole. Alright, now these two conditions are equal when the reaction is neutralized. Alright, when neutralization takes place, these are only equal at the point of neutralization. Alright, so we can say 0.5 V equals 40. Alright, so V will be 40 upon 0.5, that will be 80 centimeters cube. This is the volume of acid that is needed. Alright, you can also see that this is 0.5 molar and this is 2 mole. The concentration is very high as compared to this. That is why only 20 centimeter cube of NaOH require 80 centimeters cube of HCl. Alright, because this is a very less concentrated acid as compared to this 2 mole per decimeter cube alkali. Alright, now let's move on. 10 centimeter cube of a gaseous hydrocarbon is completely burnt in air. Total volume of the product is 70 centimeter cube. Which equation represents this? Now before you go to the maths of this equation, it is not a mathematical question at all. It is only a general knowledge question. Alright, it is telling us that whatever gaseous hydrocarbon is, its volume is 10, and whatever the products are, their total volume is 70. Alright, so we can say that this is in the ratio 1:7, and we know that equal moles of gases occupy equal volumes. So the other way around will also be true. That means equal volumes of gases will occupy equal moles. Alright, so we just need to figure out the ratios from these equations which follow this molar ratio. Alright, let's do this. 1 mole of hydrocarbon, it gives 1 plus 3, 1 plus 2, 1 plus 2, a total of 3 moles of products. That is wrong. Alright, plus this is all okay, fine. Now 1 mole of hydrocarbon is giving 4 moles of gases. Wrong, we do not get this ratio 1:7. Right, let's move on. 1 mole of hydrocarbon is giving 4 plus 3, 7 moles of gases. This is what we need. Alright, this is the right option, because in this equation we have 10 centimeter cube of hydrocarbon, and these can give 70 centimeter cube of the total products. That is what we needed. And in the next question, 2 moles of hydrocarbon are giving 6 plus 4, 10 moles. That is also wrong. We wanted a ratio, we wanted a reaction which gives 1 mole from 1 mole of hydrocarbon should give 7 moles of the products. C option is the only true one over here. Alright, MCQ 67. 1 mole of magnesium is dissolved in excess aqueous ethanoic acid. This is the formula for ethanoic acid. How many moles of oxygen will be produced? Alright, I've written the equation already because that is the first step that you need, and I've also balanced it. Alright, so 1 mole of magnesium. 1 mole of magnesium, the equation says that 1 mole of magnesium, it is giving 1 mole of hydrogen gas. Alright, so that is it. How many moles of hydrogen gas will be produced? 1. We can easily see this from the balanced equation. Alright, that's it. I hope it made things clear.